Okay, tonight's lesson is 2-5 Reasoning in Algebra and Geometry. As you go through this lesson, you need to think about the analytical thinking skills that you developed in algebra and how you can apply those same skills to reasoning in geometry. As you solved algebraic problems, you had reasons that allowed you to solve the problems to go from step to step. So when we're solving geometric proofs, we use those same type of reasoning skills and analytical skills to solve proofs. We're going to start off this lesson with some algebra review. The first problem in the review is to circle each equation. So of those four items given, circle the equation that is there. And of course, the equation that is there is 3x plus 2 equals 4. For problems 2 and 3, we're going to write an equation to represent each problem. Sarah has 5 more than twice the number of apples that Greg has. If Sarah has 21 apples, how many apples does Greg have? So twice the number is multiplication, 2x, and 5 more would be plus 5, and of course that equals 21. So 2x plus 5 equals 21. Your brother does one less than twice the number of chores that you do. If he does 7 chores, how many chores do you do? So he does one less than, which is minus 1, twice the number, so 2x minus 1 equals 7. Our vocabulary today deals with what we're going to talk about in today's lesson, which is proofs and solving proofs. In a proof, you must justify each step. So the word for the day is justify. Related words would be like justice, justification. So to justify a step in a solution means to provide a mathematical reason why that step is correct. So you make it, you explain it, and give a reasonable solution, and that allows you to answer a question and to prove something is true. So let's look at our mathematical equations we're given in column A, and we're going to map them to the property that justifies them or used to justify them in column B. Let me get this out of the way. All right, 3 plus 7 equals 7 plus 3. We change the order, and when we change order, that deals with the commutative property. In this case, we're dealing with addition, so we change the order, so it's the commutative property of addition. Similarly, let's try that again. 12 times 4 equals 4 times 12. That would be the commutative property of multiplication. So the other two are associative properties, and obviously we can figure out what's multiplication, what is addition. But the reason they are the associative property is because they change the grouping. So 2 times the quantity 5 times x equals the quantity 2 times 5 times x. So that would be the associative property of multiplication. And then the last one, because we change the grouping and its addition, is the associative property of addition. So we're going to continue reviewing the properties of equality. The first property of equality is the substitution property, which basically says if A equals B, then B can replace A in any equation. So that's a simple thing. If x equals 1, then any equation that I have x in, I can replace x with 1. Our next four properties, addition, subtraction, multiplication, and division, are inverse operations of one another. And the basic rule is simple. If you do one thing to one side of the equation, you do the same thing to the other side of the equation, and the equation stays in balance. This is how we solve all mathematical equations. So if A equals B, then A plus C equals B plus C. If A equals B, then A minus C equals B minus C. If A equals B, then A times C equals B times C. And finally, if A equals B and C can't be equal to 0, so A divided by C equals B divided by C. C can never equal 0 because that would make the equation undefined. Finally, we have 3 more properties we need to talk about. The reflexive property of equality. Reflexive is what it sounds like. It's a mirror image of one another. So A equals itself, A. Symmetric, if A equals B, then of course B equals A. And finally, transitive property, if A equals B and B equals C, then of course A equals C. So part of your homework tonight is to take this chart and to create a classifying thinking map that is a tree map of the properties of equality. So I want you to not only write down, let me give you an example. Go back to that thing. Not only write down the if A equals B, then A minus C equals B minus C. I want you to write that down. But in addition, I would like you to write down a numerical example. If 3 equals 3, then 3 minus 1 equals 3 minus 1. Something as simple as that. So do that for each property of equality this evening. So let's continue on. Another thing we need to review is the distributive property. We use multiplication to distribute A to each term of the sum or difference within the parentheses. So A times the quantity B plus C equals AB plus AC. And then the difference, A times the difference of B minus C equals AB minus AC. So we're going to use a distributive property to simplify each of these expressions. 5 times 24 is the same as 5 times 20 plus 4. 5 times 20 is 100. 5 times, well, I'm getting ahead of myself, 5 times 4. 5 times 20 is 100, and 5 times 4 is 20. So together, 5 times 24 is 120. Just a way that makes it a little bit easier to do math in your head, especially when you're doing subtraction. So 17 times 3, it's easier if we go up to 20 minus 3 is 17. So that's 20 minus 3 times 3. And then we're going to distribute that across the difference. So 20 times 3 minus 3 times 3. 20 times 3 is 60. 3 times 3 is 9. So 60 minus 9 is 51. Now, when you've done algebra problems in the past, teacher always tells you to show your work. So sometimes we have to justify steps that we use when solving an equation. So we want to figure out the value of x and justify each step. So we're given that ray AB bisects angle RAN. So since we know it bisects that angle, it cuts the angle in half. It cuts it into two angles with the same measure are congruent angles. So angle AAB is congruent to angle NAB. So we're going to use justifications below. The justifications are given to us, so we're going to fill in the blanks. These are the easy ones. So if angle AB bisects segment ray AB bisects angle RAN, that's given. Apologies. Angle RAB is congruent to angle NAB. That is the definition of an angle bisector. That's what allows us to eventually set these two angles together equal. So the measure of RAB is equal to the measure of NAB, and that's congruent angles have the same equal measure. Now I'm going to substitute, and x equals 2x minus 75. I use the subtraction property to subtract x from both sides, and I get x0 equals x minus 75. And finally, I use the addition property to add 75 to both sides, and I get x equals 75. In addition to the properties of equality, we need to learn these properties of congruence for segments and properties of congruence from angles. The properties are the reflexive property, the symmetric property, and the transitive property, and they work the exact same way that they do for the reflexive, symmetric, and transitive properties of equality. So I'm not going to go through and read through each one of those. Please make sure you understand them as you're going through your notes. So we're going to complete 10, 11, and 12 that deal with the transitive property. So if angle P is congruent to angle R and angle R is congruent to angle A, then angle P is congruent to angle A. If angle X is congruent to angle N, blank is congruent to angle Y, then X is congruent to Y. Of course, the thing that connects them together has to be angle N. And finally, if angle L is congruent to angle T, and angle T is congruent to angle Q, then L is congruent to, angle L is congruent to angle Q. Got ahead of myself there, but I think y'all figured that out. So I'm about to show you the format of a two-column proof. This is what a two-column proof looks like. You're given something, you're told that you want to prove something, so you list your statements on the left side, your reasons on the right. They'll be numbered. Statement 1, reason 1 that justifies that statement. Statement 2, reason 2 to justify that statement, so on and so forth. The first step of a proof is usually given. It's what you're given. And the last step is always what you're trying to prove. So let's look at an example of writing a two-column proof. I am given that segment AB is congruent to segment CD, and I want to prove that segment AC is congruent to segment BD. So I have all 6 of my statements listed, and I have to give reasons for each one. So first, segment AB is congruent to segment CD is what was given to us, and that's usually the first step all the time. Next, we say AB equals CD, so the measure of those two segments are equal, and that's by congruent segments have equal measure. Now, I look at segment BC, and obviously it is equal to itself, so that's just the reflexive property of equality. I know it looks like common sense, but we have to put steps like this in the proof so we can get from one step to the next. So now I can say AB plus BC equals BC plus CD. If I add the same thing to both sides, the equation remains equal. So that is the addition property of equality. So using my segment addition postulate, I can say that AC equals BD. I just combine the two segments together. And then the definition of congruence is that two things have the same measure. So now I can say segment AC is congruent to segment BD by definition of congruence. All right, let's finish up here. We'll check and see if we understand our lesson today. We're going to fill in the reasons for this algebraic proof. Just like we do geometry proofs, we can do algebraic proofs. 5x plus 1 equals 21 is given, and we want to prove that x equals 4. I can look at it and see that x equals 4, but we're going to figure out how to write a proof to prove it. So the first step in a proof is what you are given. This is always usually 95% of the time the first step of a proof. Now we're going to underline the correct words to complete each sentence. Then circle the property of the equality that justifies the step. So the first step, the number 1 was subtracted from each side of the equation. So if subtracted, it was the subtraction property of equality. Number 16, each step of the equation is then divided by 5, so we use the division property of equality. So I can take those 14, 15, and 16 and write down 3 reasons for each step to solve the proof. So I'm going to let y'all do that tonight for additional homework, and you fill in the blanks appropriately, and we will check them in class tomorrow. Please make note of any questions you have so that we can go over them in class tomorrow. This is an important lesson. Proofs can be difficult, I understand, but if we do the best we can with them, you'll do fine. I'm sure y'all will be able to handle it. So I'll see you tomorrow in class. Have a good night.